Hello everyone and welcome to this video. Today we'll show you how can make your first simulation using ROS2 and Unity. So in this video we are using this robot. This case is MyCobot ROS2. This is the GitHub repository. In the repository we can find a different kind of robot arms. But in our case we are using this one, the MyCobot 280 M5. Okay, the first step is go to this repository, copy the link, clone in your ROS2 workspace. Okay, so now clear git clone and pass the address. Okay, we are waiting to clone this repository. When has been done, now call compile to compile our package. Okay, so next step is create our project in Unity. We modify the version. In this case, we are working with 2022. ROS2 simulation Unity. Okay, the ROS2 simulation Unity, and create the project. Okay, now to make the simulation is really important that we have installed this package in our project. How we can install this package we can see in this tutorial, but in this project we repeat the different process that we need to do to install this package. So the first of all is we need to copy this link, and then we go Unity continue created the different package. Okay, done. Now go to Windows. Now we go to Windows. Okay, Windows, Package Manager, maximize a little bit, go to the plus, add package from URL, paste, and add. At this moment you need to start to install this package. We repeat the same process with the URDF importer. This is really important, and we need to make this simulation because Unity use this package to convert our URDF robot that normally uses ROS2 to make the representation and virtual application. So we need to add this and add. Okay, it's done. Clear. Don't worry for this error. Just it's fixed only with reopening the project. Okay, we open again. In this screen we can see this is the robot that we simulate in this example in this video. Okay, we have any error. Now we need to prepare the different folders. In this we want to create a folder URDF, create a folder game objects, create a folder materials, and create a folder scripts. Okay, so what is the next step? The next step is go to our workspace, find the MyCobot description, MyCobot package, then go to MyCobot description, go to URDF and copy this folder, the MyCobot 285. Copy, and then we go to our Unity project. In this case, our Unity project is ROS2 simulation, ROS2 simulation Unity, assets, URDF, and paste. Okay, now we are to simulate this MyCobot. Okay, opening. Now we need to modify, or we need to change this path, because when we are using this URDF in ROS, ROS automatically find this package and then start the import all that data or that STL file to make the representation in Airbase or Gazebo or another one. So now we copy, Control F, and replace by nothing. Okay. Now it's really important add this link, because it's the link that the base do with the world, in this case with our simulation, and we add this joint. We add the corresponding joint to this link. For this reason, go to the joint section, is here, and paste, and then change the name of this link. In this case is base link. Okay, good. Now, okay, it's done. So, how can configure the communication between ROS2 and Unity? So, let's go for ROS settings. By default, use ROS1, but in our case, we are using ROS2. We're using by default this IP address and this port. Okay. So now the next step is go to generated ROS message. As we know, when we are working with ROS, we can make a message or services. So Unity need to know if this package, or this case, if this robot that we want to simulate in Unity use this service on package. For this reason, we go to the ROS2 workspace, SR, MyCobot, go to MyCobot 218, and the interface. In the interface, the package interface, we have all the message and service that MyCobot use to communicate with your robot. So now we have 6 message and we have 6 kind of service. So now we click in bold message and boil in service. Okay, when this finish, we can see that Unity create a folder called ROS message. In this folder, Unity allocate all the message, all the service that we want to use in or to simulate our robots. Okay, perfect. Now the next step is transfer the URDF robot into a game object. To do that, we go to the folder URDF and then to MyCobot 218, and then we find this URDF. We right click and we click in import robot from selected URDF file. So import URDF, and automatically Unity start to make this conversion between ROS2, the URDF representation, to a game object. Okay, now it's finished. This is our robot. Now we add to a 3D object. In this case, I want to add a plane. Move to the 0, 0, 0. We want to change. I want to change the colors. To change the color, we need to add a new materials. Go to materials, floor, drag and drop into the object, and then go to the color and modify the visual presentation. So okay, move up a little bit the robot to go to the camera. Want to modify the position and the rotation. Modify the vernier 0.1 and the far is okay. Double click in our robot, change the name, MyCobot 280. Okay. Now hit in play, and we have a problem. What is the problem? Because the base as it need to doesn't move. It's really important. So to solve this problem, just only go to GBase, and then we need to tick in it's a base link and in a movable. Means that when we repeat the process to click in play, our robot just only move the different articulation, the different joints. So, but this movement is not a controlled movement. So, to solve this problem, we need to modify this value in stiffness and damping, the force limit, and the speed 20, and the torque and the acceleration that modify. Okay, now we click and play, and okay, so the robot at this moment just only we wait to the different angles to move the each joint. To do that is necessary use this script. In this case is called the source destination publisher. So now we click, we copy the name, and then go to the scripts, create a C# script, and just only double click and automatically opening Visual Code Studio. And in this script we copy and paste this, copy and paste here. Okay, minimize this window, and then okay, we don't have any problem. Now just only click on our robot and drag and drop the script. Then we need to convert this into a gain object. To convert this model into a gain object, drag and drop the model in our folder gain object. Then come back to our model, drag and drop the gain object into MyCobot, and then we need to add joint by joint in the script. Okay, we go here, and then we start with the joint 2 because the joint 1 is the base and the joint 0 is the joint with the reward. 4, 5, 6, and flange, and this remove. Okay, so now Unity is ready to start the communication with ROS 2. So, but we need to make this communication. It's really important that we have this package, ROS TCP endpoint. The ROS TCP endpoint is a bridge between ROS 2 and Unity. Okay, so to launch this, to be more easier launcher the different package, I recommend them to create an SS file. In this case, I have a 1H file to execute or run the TCP endpoint. Cat run TCP endpoint. That only is to the source to the setup bash and to the install setup bash, and then the command to launch or to execute the package in ROS2. Okay, just copy this because I need for the MyCobot. Okay, so now we run TCP endpoint. Okay, in this console we execute this script, and the next one here, and then we type ROS2 launch MyCobot 280 test that launch.py. Okay, this is the test. We can see this is our robot in ROS2. At this moment the real robot doesn't move because just only is a test with between Unity and ROS. Now we hit play, and we can see these two arrows. That is a bidirectional arrow, and you can see that blink the color. This means that ROS and Unity established communication, and we can use to move our robot. Okay, so but that's really good. It's interesting to move. We go to center, randomize, okay, and center. Okay, so but if we want to use the real robot, okay, go to clear. It's necessary to looking for which is the execute, which is the launch file that has the communication with the real robot using the serial port. Okay, 218 launch and slider control camera, slider control launch. We open it, and okay, in this example the robot has been connected to the USB 0, but in my case it's connected to the ACM 0, so just only need to modify this one in our scripts. Okay, now again call build. Slider control launch. I'll change this one here for the screen. Okay, it's done. Clear. Okay. And this is slider control launch, slider dot launch. Okay, now start the communication with the robot. So we can use this raw in join states. and establish the communication between the ROS2, Unity, and the real robot. So, okay. Okay, now we can move the different joints. Okay, I can see how I can move the different joints. Okay, that's all. So in the next video, we want to make the same simulation, but using virtual reality headset. Okay, thank you for watching and see you later.